In part three of the pizza delivery case, what we're going to do is take a look at a good data set. If you remember from part two, we had come to the conclusion that the data set that was created was no good, poor data collection plan, inappropriate CTQs, too small a sample size. There were all sorts of problems. And so we meet up with individuals from the pizza shop. We sit down and create a good data collection plan based on those data collection tips that are in the workbook, and we come up with a data file that you see in front of you. And in this section, some of the learning objectives, things that we'll be reviewing are when you do review current state data, how to deal with sequential versus random records, how to treat data anomalies and outliers, problems that you spot in your current state data that has been collected, um, what to do when you've identified that there is a key CTQ variable that is affecting overall performance and whether or not to drill down on it. And then finally, comparing current state performance to the specification limits that your customer has identified earlier. So when we have in our classroom discussions, when we have the class take a look at this data set and I ask them about problems with this version of the current state data, one, one concern pops out right away, and that's the fact that the data is all sequentially ordered. And it's not a random account, random records being pulled from the underlying population. We saw this also in part two. One of the issues in the data set from part two was that it was sequentially ordered. And one of the reasons why I don't mind as a first cut, not every time, but as a first cut, why I don't mind doing first cut data in sequential manner is sequential data helps you to identify missing records in the part two data set. What happened to record number 127? We don't know. That insight, though, can help us drill down to identify, is it a problem with the way that data measurers are collecting the data? Is there a valid reason? Maybe an order was just canceled. Is it a valid reason for the missing data, or is there some underlying issue that we need to address before doing any further data collection and review? Sequential, though, doesn't account for the up and down periods of any business cycle. I'd be concerned with this sequential data because it might be not a reflection of the average amount of business over the average volume of business, the average number of transactions over an average day. It could be a slow period or a busy period. If we were going to use sequential data, I'd want it to be uh, a larger collection than what our minimum sample size rules state for continuous or discrete data. Or I'd want sequential samples gathered from both the peak, the intermediate, as well as the low periods in our business cycle. So I'd be dealing with 3 sequential data sets or one very large sequential data set that represents both the busy and the slow periods. Sequential is good for spotting these missing records. But after you've cleaned that up, you may want to consider random. And so if we take a look at this next set of data, this I'll call it the improved data collection plan data. We still have that sequential issue that we'd want to take care of. Another problem that the class quickly identifies, and I'm going to zoom in so that we can see it here, is that record number 153 is definitely something's unusual here in record number 153, because if you add up all of the time that it takes to get to the delivery driver, that's 17 minutes right here. But the total lead time the total lead time in the system from the beginning of the order to the time that the customer received the pizza, that's equal to 11 minutes. And there's just no way that you can go backwards in time like that. If you started at 17 and you actually went to got there in 11 minutes, that's never going to happen in our universe. It's an example of a mistake, an error in the data set. It could be a data entry error, somebody just fat fingered on the keyboard, or it could be a situation where the 11 minutes here is really a reflection of the drive time that it took from the time that the delivery driver received the pizza to the time that they dropped it off at the doorstep. In any case, 11 minutes was a mistake. And so what do we do with it? I allow teams to throw out that outlier, that anomaly from the data set for the following reason. When we're collecting process improvement data, the goal is to capture data that is a true reflection of what's going on in current state. And this 11-minute record just could not have happened. If you've got data that is not a real reflection of current state, then it's going to be data that we're going to remove from the analysis. But if they are going to remove this record, they have to make a promise to me. And that promise is that they'll build in countermeasures solutions to prevent this type of a mistake from happening again. We sometimes call it mistake proofing. Some examples of mistake proofing could be something as simple as data validation in the spreadsheet, never allowing values for total lead time to be less than the time that it took to get to the delivery driver. It could be increased training to make sure that all new delivery drivers know not to enter drive time information, but instead to enter the total lead time in that column. Or it might be to include another column in the data set, which is just drive time, and make the lead time calculations be just an arithmetic calculation. The cumulative total time to the delivery driver, which I think we have here, the two driver time. I'll call it two driver time, plus a new column. Maybe we call that column drive time, and that information is included, and that drive time information is included in a separate column in the spreadsheet of data that is collected. All these are examples of mistake proofing the system. How did we identify that mistake? Well, it's easy when you've only got 20, 30, 40 records that you need to analyze to spot that missing record. It just pops out on the screen. But what if you had 300, 3,000, 3 million records? In situations like that, it's nice to have a visual display of the data to help identify anomalies or outliers. Histograms are a great visual tool to help you with outlier analysis. In part 4 of the pizza case, we'll take a look at using histograms to help with variation analysis.